Okay, today we're going to talk about binary addition. Dun, 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 dun. Binary addition. Okay. There's many ways you could go about doing binary addition. This is where we're adding two binary numbers. So suppose I have a number like this. I have 1, 1, 0, 1, 0, 1. And I add that up with 0, 1, 1, 1, 1, 0. Okay? Add these two numbers together. The most straightforward way to do this, for those of us who know how to convert between binary and decimal, is to just take these two numbers. So I'll label these numbers x and y here. Take these two numbers and convert them into decimals. So we're going to have take these two numbers, convert them to decimal, and see what those are. So just review. So we have our 1s, our 2s, our 4s, our 8s, our 16, and our 32nds, and our 64s place, let's say. There's something in the 64s place. I'll just preprint these with zeros. No difference here, but so okay. Let's see. I have 32 plus 16. So 32 plus 16 is, let's see, 48 plus 4. 48 plus 4 is 52, and then 53. Okay, that's 53. And this number over here, let's see, that's 16 plus 8, so that's going to be 24, plus 4 is 28, and okay, that's plus 2 is 30. Okay, so we add these two numbers together. So what we end up with is, let's see, 83. Okay. Now we can convert this number here, 83, back into binary. So what we would do is we would take the highest power of 2 that can go into 83, which happens to be 64, because 128 is larger than 83. So we'll just take out 64. Okay, so we'll just put our 64's place. We'll say, okay, we took out 64. So whatever that is, let's see, 83. Take away 64. What we got to do? That's going to be let's do a quick addition here. That's going to be 13 minus 4 is 8? No, 9. That's 19. Okay. So 19. All right. So 32 doesn't go into 19. So there we go. But 16 does go into 19. So I'm going to say yes, it does. So I'm going to subtract away 16 from that. So now I have 3 left over. So if I go through, okay, well, 8 doesn't go into 3, nor does 4, but 2 and 1 together, we can just verify that. Subtract away 2, and then we end up with 1, and then 1 goes to 1. Voila, we end up with this fancy number here. So this is basically the conversion from 83 back into binary. So that's what we're doing there. So we're taking these two binary numbers, and we're converting them to decimal, taking that decimal result and converting it back into binary. This is how how you and me might do this. How we might go about doing this addition. So it looks pretty straightforward. Okay, well, that's easy, right? That's the easy way to do it. But of course, this is not how your computer does it. Your CPU will do it a very different way. Instead of doing it this way, instead of doing this conversion, instead it's going to do this addition directly. So let's take a look at how it does that. Okay, so at the lowest level, we can think of just adding each bit separately. Okay, so suppose we have x, and suppose we have y, as before. And what we do instead is we look at each of these separately. So we have 0 plus 0, we have 0 plus 1, we have 1 plus 0, and we have 1 plus 1. Okay, so 0 plus 0 is going to be 0, 1, okay, 1. Okay, now we have 1 plus 1. Now that's going to be 2, right? That's 2, but now 2 is not a base 2 number, so that's not quite right. What we should say instead is, well, what's 2 in binary, right? That's going to be 1, 0. Okay, but now we have a problem, right? All these other guys have just 1 bit, right? 0, 1, 1. Okay, those are all just 1 bit, where this is 1, 0. There's 2 bits. Okay, well, we got to make sure that everything fits properly. So let's just name these bits here. So this bit over here, this least significant bit, is actually going to, the name for this is going to be our sum bit. Whereas this guy over here is going to be our carry out bit. Okay? And we'll see why these are called that in a moment. But suffice it to say, these other guys, for their carryouts, are going to be just 0. So, and by the way, let me just abbreviate this a little bit. So instead of writing out this whole carryout bit, I'll just call this C out, kind of like C++. And this is going to be our sum. Let's just say S for that. So C out and sum. Looks like a 5. Okay. C out and sum. Okay. So what this is right here, by the way, is what's known as half adder. Okay, so we have a half adder here. It's so called, it's a half adder because we're not really taking into account all possibilities. Actually, we're taking into account only half of our possibilities here. What we have neglected to look at actually is what if we're carrying in a bit over here? What if we want to add in, say, an extra number here? Half adders don't take care of that situation. So if we want to do what's known as a full addition, which we'll get to in a moment, we have to take into account this carry in bit. Now, before I get to that, by the way, I just want to mention if we're saying we have a carry in, so suppose we say, okay, we're going to carry in a bit. In the half adder, we're assuming that we're carrying in nothing. So we're going to just implicitly say that's 0 right there. So 0 plus 0 plus 0, okay, it's still 0. So add 0 to anything, it's going to be whatever we just added in. So okay, but we want to ultimately do is a full adder. So let's just do that. So a full adder is everything a half adder does and then some. It also takes care of this carry in. Now, I'm going to assume that, as before, our carry in is going to be the same. That is, we're going to have zeros over here. So actually, this whole thing here works out just the same as it would. So we're going to look at, instead, what if the carry in bit's going to be a 1? So let's just take a look at that. So we're going to just say 1, 1, 1, and 1. And then I'll just do the addition as before. So we have our x and we have our y. So we're going to add these things up. So we have our 0, 0, 0, 1, 1, 0, and 1, 1. So we're just going to add those all up. So this, by the way, are all the possibilities now that we're taking care of. So 1 plus all this stuff, that's just going to be 1. So the sum is 1. Our carry in is 0. Or sorry, our carry out is 0. This is our carry out. There's sum. 1 plus 1 is 2, but in binary that's just going to be 1, 0. So C out. There's our sum. Okay. 1 plus 1, same thing over here. This is going to be our sum. So it's, okay, great. And then finally, 1 plus 1 plus 1. Okay, so that's 3. And in binary, 3 is just going to be 1, 1. Okay, so this is kind of nice. It works out really well. We have our carry out and we have our sum bit. Okay. And so now this actually takes care of every single possibility. So if we have, if we're carrying 0 here, it works out this way. And if we're carrying 1 in, it works out this way. The full adder actually is this whole thing. So it's not only what a half adder does, it's what the full adder does as well. So I'll just kind of draw a little bubble around that. Okay, wait. I have more screen real estate than I can. Anyway. So a full adder is this whole thing. So it's everything a half adder does, plus we're taking into account these extra possibility that the carry in is also 1. Okay. So all right. So there's our half adder, and there's our full adder, and the full adder includes everything that the half adder does. So let's draw this out as a truth table, right? Let's just do that really quick. The truth table is a lot more compact. So, all right. So we'll just say we have our x, we have our y, and we have our carry in, and we're also going to have over here our carry out and our sum. Okay. Let's see. Okay. So I'm going to just draw the truth table the traditional way. I'm going to start at 0, and I have 3 variables here. So that's 2 to 3 is 8. So 8 minus 1 is 7, so I'm going to just say, all right, well, 0, 0, 0. Now I can do the fast ways of 0, 1, 0, 1, 0, 1, 0, 1. Okay. 0, 0, 1, 1, 0, 0, 1, 1, and then finally 0, 0, 0, 1, 1, 1, 1. Huzzah. Okay. So now, what I'm going to do in this truth table, by the way, this is our full adder truth table. So truth table. What I'm going to do is I'm going to just add these things up. So all I'm doing here is I'm just going to say, okay, for each of these bits, I'm just going to add them up together. So, and this is really, there's nothing really fancy about what I'm doing. In fact, you should be able to reconstruct this truth table on your own without any effort. So if you see what I'm doing, it's really no mystery here. Okay, so if I say, what's 0 plus 0 plus 0? That's, okay, that's 0, all right. 0 plus 0 plus 1, okay, that's going to be 1. Likewise, same thing over here, but now, okay, 1 plus 1 is 2, in binary that's 1, 0, okay? And by the way, we write it out this way, carry out, then sum, that way it works out just nicely, like this 1, 0 is 2 in binary, okay. So there you go, so we have 0, 1, 1, 0, 1, 0, and then 1 plus 1 is 3, which in binary is 1, 1. Okay, so there's our truth table for our full adder. Okay, so now we have this truth table here. Let's go back to our original example. So we originally had this guy over here. We had these numbers here. And let's take a look at how we would do this sort of binary addition the way a CPU would do it. So the way a nice little Intel chip might do this, right? This is my rendering of an Intel chip right here, our CPU, right? Okay. I have only, yeah, okay, well anyway. Okay, so we have these numbers here, so let me just copy this down. So we had 0, 1, 1, oopsie, 1, 1, 0, 1, 0, 1. And we also had, that's going to be plus, let's see, 0, 0, 1, 1, 1, 1, 0. Okay, so these two numbers together. So the way a CPU would go about doing this, rather than converting from binary to decimal and back, we're going to say, okay, well, 1 plus 0 is just going to be 1, and we carry nothing. So, by the way, we're going to write our sum bits over here. We're going to write our carryouts over here. Okay, so 1 plus 0, I should say, is 1. Okay, carry nothing. Okay, this is just going to be 1. Okay, carry nothing. 0 plus 1 plus 1 is just going to be, that's going to be 2, right? 1 plus 1 is 2, so we're going to sum is 2, but our carryout is going to be 1, so 1 plus 1 now is going to be 2 again, so we'll just say, all right, well, all right, we carry a 1, it's 1, 0. So 1 plus 1 is 3, so we're going to write down a 1 here, and we're going to write our carryout as a 1. So 1 plus 1 is, sum is 0, but the carryout is going to be 1, and then voila, okay. But guess what? Check it out. If we look at these two numbers here, right, and this number over here ends up being the exact same number, right? Let's just verify that. 1, 0, 1, 0, 0, 1, 1. Yeah. So, nice, huh? That's how it works. That's how your CPU adds two binary numbers together.